Hello everybody! In this video, we will be exploring how to satisfy the given conditions of some algebraic statement. To do this, we have some example problem here. It says, consider the function h of x that's equal to 2x minus 1. I want to find the x values that make this function h of x greater than 0. And so one thing that I just want to make sure that all of us are comfortable and familiar with before we dive into this is the fact that h of x is the name of our function. Typically, we use a standard name of functions. We use the letter f for f of x, which represents another standard name of a function. But of course, we could have multiple functions. I can have f of x, h of x, b of x, a of x, c of x, d of x, anything that I need of x represents the function using the function notation. But most importantly, we want to know that the f of x symbol in mathematics represents the y variable. It's exactly equal to the y variable when we're dealing with a relationship x and y. And so the reason I'm saying this is because we want to think like, h of x greater than 0. If I know h of x is really just y, my y variable, then I'm really just wondering what x values make y greater than 0. And where is y greater than 0? Well, I see y is greater than 0 everywhere above the x-axis in these two quadrants here. And so ultimately, all we're really trying to figure out is where is my function h of x greater than 0. I took it upon myself to just draw a little sketch of our function, 2x minus 1. I'm trying to figure out where it's greater than 0. Of course, I can see visually it's greater than 0 here, but I want to know exactly what x values make that happen. And I see that we're looking at an x value right here, some point, and all of the x values to the right of that, because all of the x values to the left of that, we see that they have negative y values, and we're looking for the positive ones. And so I'm just wondering, where is this greater than 0? Well, if h of x is greater than 0, and we know h of x is really just 2x minus 1, then we're really just trying to figure out where is 2x minus 1 greater than 0. And then looking at it this way, it's much simpler. It's just a basic inequality that we learn how to solve in Algebra 1, sometimes pre-algebra. I want to get x by itself on the left side of my inequality. I need to get rid of the 2 and the negative 1. I'll get rid of that 1 first. I see it subtracting, so I'll add it. If we do it to one side, we know we do it to the other side. Poof, it's gone. All I have left on the left side of this inequality now is my 2x, nice. On the right side of the inequality, I have the number 1. Last step I have to do is just divide that 2 out on both sides, and I see that x is greater than 1/2, which makes sense. It says that when x is greater than 1 over 2, then we're having positive values of our function, and we can see wherever x is less than 1 over 2, these values over here, those give us the negative values of our function. So I know that this point here has the x value of 1/2 and the y value appears to be 0. And so what x values make this function greater than 0? Well, it's the x values where x is greater than 1/2. This was more of a logical problem, so I'm going to try to answer with a sentence. So I'll say we know h of x is greater than 0 whenever x is greater than 1 over 2. And there we have it.